Keen. 350 years after the gauntlet was thrown, Keen, a professor at Princeton University, has finally attained this holy grail of mathematics. He has constructed a proof for Fermat's last theorem and become world famous as a result. So, what happens when you leap overnight from obscurity to international renown? First, like it or not, you have to meet the press.
Hey, Benny, how's my makeup?
But I flunked math.
This man is a math god.
I can't wait to hear how he explains this to the master.
This is my Over there. Over here, Professor Keen.
Professor Keen, over here.
Over here, here's a question.
Over here, Professor Keen.
Is that him? He looks so nerdy.
He's a math professor. What did you expect?
I don't know.
Professor Keen, is it true?
Fill us in.
What's the scoop?
Is it true, Professor Keen?
Who is Fermat?
How's it feel?
What's the deal?
What did you do, Professor Keen?
He seems so quiet, unassuming.
A stiff that needs entombing.
All these passions all consuming.
He must be a little bit crazy. He must be a little bit crazy.
Must be a little bit crazy.
7 years he spent shut up in his attic, trying to come up with a proof. Now comes the main event. In matters mathematic, the world's curiosity grows. We want to find out what he knows.
Reporting here live for Channel 5 on June 23rd, 1993. We're here with Professor Daniel Keen, tonight's hot name on Evening Magazine.
Is it true?
Do you really have a proof, Mr. Keen?
What is a proof and who cares?
Don't be aloof, Mr. Keen.
He proved Fermat's last theorem. The math world is elated. We hope we understand it. It's very complicated. Tell us what you've done. Tell us how you solved it. The most famous problem of all time. Tell us how you spun, worked it, and evolved it. This proof no one else has been able to find. That's boggled all the greatest brains of humankind. Now has come the moment for the truth to unwind. Another proof was given several years ago. A different problem solved. As some of you may know, this proof stated beyond all doubt that a certain conjecture, an unproved conjecture, the Shimura-Taniyama conjecture, should it prove to be true, implies a corollary you could apply to Fermat, which would mean that Fermat, beyond a doubt, that Fermat was right.
What the hell does that mean?
I haven't got a clue.
What's he saying?
How did I do you? Hush, this is important.
I proved the conjecture, the unproved conjecture, the Shimura-Taniyama conjecture. Yes, I proved it to be true. And by extension, Fermat's last theorem, Fermat's last theorem, too. Simplify, Professor, simplify, Professor. Edify, electrify, and educate. It's up to us to help our readers understand it. So tell us, what exactly does the theorem state? Well, do all of you know of Pythagoras?
Yes, Professor Keen, we do.
Pythagoras? Does he teach at Princeton too?
No.
Shut up.
Fermat's last theorem is the general case of a statement which was proved by Pythagoras.
Was this last year? I think I read about it.
What are you doing here anyway?
I usually write the Sunday feature, but the science guy's out with the flu.
Pythagoras was an ancient Greek, the father of mathematics. As Pythagoras said, for every right triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Or in other words, many square numbers can be divided into two other squares, but according to Fermat, you cannot make it work. 4 cubes, or 4s, or 5s, or 6s, or more. In fact, there are no whole number solutions where n is greater than 2, not 3, and not 10 million. That is the theorem, Fermat's last theorem, for which I have a proof.
Why is this important? Why is this important? What is so significant that we all should care?
Over here, Professor Keene.
Professor Keene, over here.
Over here, here's a question.
Over here, Professor Keene. What's he done? He says he fixed it.
Is he sure this time the proof is really sound?
Well, it is.
How would you know?
Horizontal Iwasawa theory was the answer. Gave the same result the Euler system gave. Once the mapping was class number formulaic, Galois theory still could make the curves behave.
He's right.
Well, some of us did our homework.